We are going to see today a problem for the 10th standard CBSE Mathematics, Chapter 9, some applications of trigonometry. This is a little bit of tricky problem in which the 16th question, Ex.9.1, question number 16. The angles of elevation of the top of a tower from 2 points at a distance of 4 meters and 9 meters from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is 6 meters. Well, we have to think a little bit. We have to draw the figure first and then form two equations using the appropriate trigonometric ratios in the two right triangles formed. Since the product of trigonometric ratios of complementary angles is always 1, we can use this concept to multiply the two equations to obtain a single equation in one variable. Then of course we can solve it to get the answer. This is the required figure. Now we can see AQ, it is marked as AQ, is the tower. We have to find the height of the tower. We have to prove that the height of the tower, that AQ is equal to 6 meters. AQ. We have two right triangles. We have assumed that one angle is theta and the other angle ARQ. The angle ARQ, the angle of elevation of the tower from a point on the ground, that is from a point R on the ground, is theta, and the angle of elevation from another point S on the same horizontal line on the ground is 90 minus theta, which is complementary to theta. So we are also given that the distances of the points R and S as 4 meters and 9 meters respectively. This is also given. So based on this data, we will be proceeding to, we have two right triangles as you can see, angle AQR and angle AQS. So these are the two right triangles. Let us proceed to let the one angle be theta and the other angle will be 90 minus theta as shown in the figure. This is the figure there. You can see the figure now, theta and 90 minus theta. Now, first step is to form two equations, the two equations using the trigonometric ratios. Let us take in triangle AQR, which is a right angle triangle. We have AQ by QR is equal to tan theta, opposite side by the adjacent side. We are given QR is equal to 4 meters. Refer to the figure. The QR, the distance QR is given as 4 meters. So, we have AQ by 4 is equal to tan theta. This is the first equation. Next one. In triangle AQS, the next right angle triangle AQS, Look at this figure. AQS in the right angle triangle AQS. What you see, you will see that tan of 90 minus theta. 90 minus theta AQ by QS. Yes, AQ by QS. That's what we get here. AQ by QS is equal to tan of 90 minus theta. You know that tan of 90 minus theta is cot theta. Complementary ratio. Ratio of trigonometric ratio. The trigonometric ratio of complementary angles, tan will become tan of 90 minus theta is cot theta. So we have another equation. AQ by 9, since QS is equal to 9 meters, AQ by 9 is equal to cot theta. This is the second equation. Now we have two equations. AQ by 4 is equal to tan theta, equation number 1, and AQ by 9 is equal to cot theta, equation number 2. Now, coming to the next step 2. We multiply these two equations which involve the trigonometric ratios of complementary angles so as to get a single equation with 1 on the RHS, because we know that tan theta into cot theta is 1, which is nothing but cot theta is 1 by tan theta, so tan theta will get cancelled. So we will get AQ by multiplying the two equations, we get AQ by 4 into left hand side. You have to multiply the left hand sides and also the right hand sides and equate them. So we are going to do that. So AQ by 4 into AQ by 9 is equal to tan theta into cot theta, that is equal to 1. So AQ squared by 36 is equal to 1. AQ squared is equal to 36. AQ taking the square root, we will be getting plus or minus 6. But since the height can't be negative, the height of the tower should be 6 meters. Hence, this is proved that the height of the tower is 6 meters. Thank you.